pull up a chair. Seriously, I need you looking at my screen right now because the Learning Portal is currently experiencing a full-blown outage in production. You and I have exactly 8 minutes to diagnose and resolve this issue on our live server, and we're going to do it using just 7 essential Linux command line interface commands. Welcome to this explainer. Today, I'm going to walk you through exactly how senior engineers handle high-stakes incidents.
We are in a highly stressful, high-pressure scenario. Customers are getting errors, alerts are literally firing off, and the clock is ticking. Think of this as looking right over my shoulder in a live diagnostic session. We've just SSH'd into the box, and we're staring at a blank, dark terminal. We need answers fast. Let's find out why the Learning Portal is down.
Okay, Phase 1. Assess the system state. Let's dive into this and see what's actually running. Before we start wildly guessing what's broken, we need to know what is currently running, or, what's crucially failing to run on this machine. We need a snapshot of our resources. So our first move is checking our processes. We use the command psaux and pipe it into grep nginx, just to verify if our web application actually started. It gives us back some absolutely crucial metrics: the user, process ID, and specifically the percentage of CPU and memory this process is just eating up. This is your immediate check for resource hogs that might be melting down the server.
But we also need to decode that output header, specifically looking at that stat column. And honestly, this brilliantly illustrates what a bad day in DevOps looks like. If you ever run this command during an incident and spot a capital Z in that stat column, you've got a zombie process. It basically means a process has completed execution but is still lingering around in the system process table, completely tying up resources. Seeing a Z is a massive red flag.
Right, so once we check the processes, we immediately move to the network. The command netstat-tulnp needs to be pure muscle memory for you. This command shows us every single open port on the machine and, more importantly, it definitively checks which application owns that port.
When you hit Enter on that netstat command, your eyes need to dart straight down the list looking for port 3000. Why? Because that is exactly where our specific Node.js application runs. We need to see if it's actually actively listening for connections. In our scenario right now, the port is open, the app is listening, but users are still getting errors.
So, moving on to Phase 2, locate and read logs. Let's dig in and find the errors.
Okay, the app is technically running, but it's clearly struggling. We know the heartbeat is there, but we need to find out exactly what the application is screaming about. We do that by locating the log file that was just modified. Now, you already know the basic ls command, but ls-l-a-t-h is the version DevOps engineers actually use after a deployment or during an outage. The L gives us the long format with all the permissions, A shows the hidden files, H gives us human-readable sizes, and T is the magic key here. It sorts the output by time, dropping the newest, most recently written files right to the top so you see exactly what just changed.
So we found the active log file. Great. But production logs contain thousands upon thousands of lines of data being written every single second. How in the world do we find the single signal, the exact error causing our outage, in all of that chaotic production noise?
Enter the single most critical incident response tool for log reading, grep. But we aren't just doing a simple search for the word error. No, we chain grep with the -B2 and -A2 flags. This literally stands for before and after. It pulls the 2 lines before the error and the 2 lines after. This instantly gets us the real-time context, revealing an exact null pointer exception that killed the database connection after 3 retries. Boom, we found the killer.
All right, Phase 3, slice data and analyze. Let's crunch these logs and see the impact. Now that we know what the error actually is, we need to analyze structured data from those logs to calculate the severity and impact of the exception we just found. Now, what's really interesting about this step is how we handle that structured data. People always get so intimidated by the awk command, but seriously, don't be. Think of awk simply as a column selector. If you have comma-separated values, like this simple user data, username, plan, videos watched, awk can instantly pull out exactly the columns you need without you having to write a whole Python script just to do it.
Let's apply awk to a live DevOps example with our current logs. We use it to filter for successful 200 responses, and then we extract and average the very last column. That's the $NF, or number of fields. In our specific log format, that last column represents the response time in milliseconds. By doing this, we can instantly see the average response time. If it normally averages around 12 milliseconds and right now it's jumping all over the place, well, we know for sure the application is severely degraded. Okay, phase 4. Execute the fix. It's time to actually patch this server.
We track that null pointer exception down, and you know what it was? It turns out someone accidentally pushed a bad development configuration file straight onto this production server. The app is out there trying to talk to a local database that just doesn't exist, and we need to fix it live, right now. To do this quickly and safely across the whole file, we use sed, the stream editor. It is your best friend for in-place file editing. We run a command swapping the word development for production globally in our app.conf file, and the configuration updates instantly. Our environment variables are correct again,
But, and listen to me very, very carefully on this one, always preview sed without the -i flag first. Always. That -i stands for in-place edit. If you use it, it immediately modifies and overwrites the actual file. If you kind of mess up your search pattern, you can destroy a massive critical configuration file in a millisecond. Run the command without -i first to see a preview in the text stream output, verify it's absolutely correct, and only then run it with -i to execute the fix.
Okay, scratch that. Just as we patch the config, another alert flashes. We have a secondary error escalating this high-pressure scenario. Disk usage on the var partition has just exceeded a critical threshold. It's sitting dangerously at 94%. If that hits 100%, the entire server crashes. We require rapid file cleanup right this very second.
So, the crucial point is how we locate and destroy that dead weight fast. We use find, but find alone just lists files, right? The absolute power move here is chaining find with the -exec flag. We find every .backup file in the temporary directory and immediately execute a remove command on it. This locates and instantly cleans up sloppy backup files, files that were actually silently storing raw database passwords left behind by a previous editor. We just saved the disk space and closed a major security risk in literally one keystroke.
Finally, Phase 5, the CLI diagnostic mindset. Let's move to the recap and see how this builds your workflow.
The disk space is dropping, the config is fixed, the app is resolving connections normally again, the outage is officially over. Take a breath, now let's see how this builds your overall engineering intuition. We just executed a really fast, confident chain of commands. Look at the logical 5-step diagnostic path we just used, in under 2 minutes, to successfully identify and resolve a massive outage. We didn't panic, we checked our running resources with PSX, we checked our ports with netstat, we found the bleeding edge of the logs with ls-l-8-t, we extracted the exact context of the error using grep, and we executed an in-place configuration patch using sed.
Here is your absolute final cheat sheet. Honestly, take a screenshot of this. These 7 commands, ls, grep, awk, sed, find, ps, and netstat, they form a mental model that will carry you through, I'd say, 80% of everything you will ever do on a Linux server. Master these and you literally stop guessing and start actually diagnosing.
But here is the ultimate question to leave you with as we wrap up this explainer. You've seen the raw power of running these commands manually during an incident. So, how will you combine these 7 commands into an automated bash script to detect and resolve these issues before the server ever even goes down? Think about that, because automating this CLI mindset is exactly where we're heading next. Keep learning, and I will catch you in